Hey there, future space explorers, and welcome to your final mission briefing. We are about to blast off into the world of rockets to make sure you are totally ready for your big exam.
Okay, team, listen up. Here's how this is going to work. I'll ask a question, and then you'll get a few seconds to hit pause on the video and really think about your answer. Once you're ready, just press play, and we'll reveal the answer and talk about it together. Ready for launch? Let's do this.
All right, let's jump right in. First up, we're talking about why we even build rockets and where we send them. So here's your first question. For what two main purposes are rocket systems used? Go ahead and hit pause and have a good think.
So what did you get? The answer is for space travel and as weapons. Yep, that's right. On one hand, rockets do these amazing things like carrying people and cool equipment into space for exploration. But on the other hand, they can also be used as really powerful missiles. Kinda wild, right? Two totally different jobs for one incredible machine.
You're off to a flying start. Let's keep that momentum going with question 2. Name 2 places where humans have used rockets to land vehicles. Come on, think about some of the famous space missions you've heard about. Pause here and give it your best shot.
Did you get it? We've landed vehicles on the Moon and Mars. We, of course, famously sent astronauts to actually walk on the Moon, which is amazing. And more recently, we've used these massive rockets to land some incredible robotic rovers on Mars. They're like our little robot explorers on the Red Planet. How cool is that? Okay, time for section 2. Now we're diving into the science of how a rocket actually flies. It really is all about energy. So your first question for this section is, what is the input energy a rocket needs? You know, what do we have to put into it to make it go? Go on. Pause and think. The answer is the energy that's stored right inside its fuel. Think about it. Just like a car needs petrol to get going, a rocket needs its own special fuel. And that fuel is just packed with a ton of stored energy, what we call potential energy, just waiting to be unleashed.
Awesome. So that leads perfectly into our next question. If the input energy comes from the fuel, what is the output energy of the rocket system? What kind of energy does all that fuel actually create? Take a sec to think it over.
And the output is fast upward movement energy. All that stored energy that was just sitting in the fuel gets converted or changed into this incredibly powerful movement that literally shoves that giant rocket up, and away into the sky, fighting against gravity every inch of the way.
So yeah, you can see the whole process right here. You start with that input energy, all that power stored in the fuel. The rocket's engines do their magic and convert it into output energy, which is just awesome, fast upward movement. Pretty straightforward when you break it down.
Okay, let's get into the nitty-gritty. So, in simple terms, how does hot gas actually push a whole rocket up? I want you to try and explain this one in your own words. It's a lot like when you blow up a balloon and then just let it go. How does that work? Pause here and think about it.
Okay, here's the secret. The rocket's engines burn all that fuel, and that creates a massive amount of super hot gas. All of that gas has to go somewhere, so it gets forced out of the bottom of the rocket at super-duper high speed. And as all that gas pushes down, it creates an equal and opposite push that shoves the rocket up. Now, this whole idea of pushing one way to go the other way, that's not just a neat trick. It's actually a super famous rule in science. So, question 6, which scientist's third law explains how both rockets and balloons move? This is a really big name in the world of science.
Of course. It's Sir Isaac Newton's third law of motion. I bet a few of you knew that one. He was this absolutely brilliant scientist who figured out a lot of the basic rules for how everything in the universe moves. And this law is one of his most important ones for sure.
And this is the law itself. This is what Newton's third law says. For every push in one direction, there is an equal push in the opposite direction. It's that simple and it's that powerful. So just remember, the rocket pushes the gas down, so the gas pushes the rocket up. It's like a perfect scientific deal.
Moving on to our next puzzle. We know rockets need fuel to burn, right? But they need something else to help that fuel burn. So question 8 is, why do rockets have to carry oxygen with them when they fly so high? What's missing way up there in the sky?
And here is why. You know how for any fire you need 3 things, fuel, heat, and oxygen?
Well, down here on Earth, oxygen is everywhere. It's just in the air all around us. But once a rocket gets really, really high, about 25 kilometers up, the air gets super thin, and there's just not enough oxygen around to keep the engines burning. So the rocket basically has to pack its own lunch and bring its own oxygen.
You are doing fantastic work. Welcome to our final section, Building for Space. This is all about what rockets carry and what they're made of. So, first question for this part. What is the special name for the people, equipment, and spacecraft that a rocket carries? It's a cool scientific word. Go ahead and pause.
The correct term is the payload. That's it. The payload is the whole reason for the rocket's trip. It might be a new satellite, a giant telescope to look at distant galaxies, supplies for astronauts, or even the astronauts themselves. It is the rocket's precious cargo.
Okay, next up. Imagine the rocket has done its job, it's delivered its payload safely. So, what happens to the main part of the rocket when all of its fuel runs out?
Well, it stops, and it falls back to Earth. As soon as the fuel is gone, there's no more upward push coming from the engines. And you know what's been pulling down on it the whole time? Gravity. Gravity finally wins the battle, and the empty parts of the rocket fall back down towards the planet.
All right, astronauts, this is it. The last question. So think carefully. If you want to build a rocket that can carry a really, really big and heavy payload into space, what two properties must that rocket have? What two things does it need to be?
And the answer is, a rocket must be strong and light. Now, what's so interesting about this is that those two things kind of seem like opposites, don't they? But a rocket has to be strong enough to not fall apart from the incredible power of the launch, but it also has to be as light as possible so it's easier to escape Earth's gravity. It's a seriously tricky challenge for the engineers.
And mission complete. Excellent work, everyone. You made it through all the questions, and you are absolutely ready for your exam. Seriously, great job. Before you go, I've got one last thought to help launch your imagination. Where in the whole universe do you think we should send a rocket next? Good luck on your exam, and remember to keep looking up.